Good day, and welcome to Astronomy Daily, your go-to source for everything happening in space and astronomy. I'm Anna.
And I'm Avery. It's Thursday, February the 12th, 2026, and we have a packed show for you today.
We really do. China has just pulled off a major milestone in its push to land astronauts on the moon, including a pretty spectacular rocket splashdown that should have a few people at SpaceX paying attention.
We've also got ULA's Vulcan Centaur rocket launching a pair of space surveillance satellites for the U.S. Space Force, a deep dive into why Artemis 2 has so few chances to actually get off the ground, and a stunning new Hubble image of a dying star.
Plus, did NASA's Viking missions actually find life on Mars 50 years ago? New research says the answer might be yes. And astronomers are still hunting for the remains of a comet that dramatically fell apart during COVID lockdowns.
Let's get into it.
Our lead story today takes us to Wangchang Space Launch Site on the island of Hainan, where yesterday, February 11th, China conducted a landmark test that checked off multiple firsts in a single mission.
This was a low-altitude demonstration flight of China's next-generation Long March 10 rocket, carrying the Mengzhou crew capsule, and what they were testing was something called a Max-Q abort. Basically, can the capsule safely escape the rocket at the moment of maximum aerodynamic stress during ascent?
And for context, that's the point during any rocket launch where the vehicle is experiencing the greatest combination of speed and atmospheric resistance. If something goes wrong at Max-Q, the crew needs to get away fast. This was China's first ever test of that scenario with a crewed-class spacecraft.
The capsule successfully separated from the rocket, deployed its parachutes, and was recovered at sea. It was carrying lunar spacesuits and test dummies rather than actual taikonauts, obviously, but the abort system performed exactly as designed.
Now, here's where it gets really interesting, Avery. After the capsule separated, the Long March 10 first stage didn't just tumble into the ocean. It performed a powered vertical landing, a soft splashdown at sea, very much in the style of SpaceX's Falcon 9 booster recoveries.
And that's a huge deal because until now, only the United States has had operational reusable orbital-class rockets. This was China's first successful rocket recovery attempt, and it worked on the very first powered flight of the Long March 10 prototype.
And they even had a dedicated autonomous recovery vessel called the Linghangzi standing by, which is essentially China's answer to SpaceX's drone ships.
The full Long March 10 is going to be an absolute beast when it's complete. A tri-core rocket standing around 90 meters tall with about 2,700 tons of liftoff thrust. It's designed to be China's largest launch vehicle and the only one capable of sending both a crew spacecraft and a lunar lander to the moon in a single launch.
If things continue at this pace, China is projecting a full orbital flight of the Long March 10 by 2027, with taikonauts on the lunar surface before the end of the decade. That puts them in a very real race with NASA's Artemis program, which is targeting its own crewed landing with Artemis 3 no earlier than 2028.
And this test was conducted from the brand new launch pad number 3 in Wangchang, which was built specifically for these lunar missions. So the infrastructure is going in alongside the hardware.
A genuinely significant day for the Chinese space program, and one that adds real momentum to what's shaping up to be the most exciting moon race since Apollo.
Sticking with rockets, but moving to Cape Canaveral, ULA's Vulcan Centaur rocket is set to launch early this morning, February 12, with the window opening at 3:30 a.m. Eastern Time.
This is the fourth Vulcan mission overall and the first of 2026. The payload is a pair of GSSAP satellites. That's the Geosynchronous Space Situational Awareness Program, built by Northrop Grumman for the U.S. Space Force.
Think of GSSAP as a neighborhood watch program for geosynchronous orbit. These satellites monitor other spacecraft at that critical 35,000-kilometer altitude, improving flight safety and giving Space Force operators better situational awareness about what's happening up there.
There's also a secondary payload called Propulsive ESPA, essentially a training spacecraft that Space Force Guardians will use to practice precision orbital maneuvers and validate techniques for protecting assets in orbit.
What's notable about this particular mission is that it's the longest Vulcan flight to date, nearly 10 hours, because the Centaur upper stage is performing a direct insertion all the way to geosynchronous orbit, rather than just dropping the satellites into a transfer orbit.
ULA is under some pressure this year. They've got interim CEO John Elbon at the helm after Tory Bruno departed to join Blue Origin late last year, and they're targeting 18 to 22 launches in 2026, after falling short of their targets in 2025.
They've invested heavily in infrastructure, a second mobile launch platform, and a second integration facility at the Cape. So the capacity is there. The question is whether Vulcan can deliver on the reliability and cadence that their roughly 80 mission backlog demands.
We should note that ULA's webcast coverage will end at fairing separation, about 5 minutes after launch, because the classified nature of the payload means the rest of the mission is conducted in silence. Now, speaking of getting rockets off the ground, let's talk about Artemis 2, because if you've been following the countdown to the first crewed moon mission in over 50 years, you might have noticed something surprising about how few chances there actually are to launch.
NASA has published the available launch dates, and there are just 11 opportunities across March and April combined. 5 dates in March, the 6th through the 9th, plus March 11th, and 6 in April. Each window is about 2 hours long.
11 chances in 61 days. That's it. And some of those could be lost to weather or the need to replace consumables like rocket fuel. So why so few?
It all comes down to orbital mechanics and the specific requirements of this mission. Artemis 2 doesn't fly straight to the moon. The SLS rocket first delivers the Orion capsule to high Earth orbit, where the crew and ground teams run through a series of checkouts. Then comes a translunar injection burn to send Orion on its way.
So the launch time on any given day has to thread the needle. SLS needs to reach the right orbit. Orion needs to be in the correct alignment with both Earth and the Moon for that translunar injection burn, and the whole trajectory has to work as a free return loop using the Moon's gravity to sling the capsule home.
And then there's a power constraint. Orion's solar arrays can't be in darkness for more than 90 minutes at a stretch, so NASA has to rule out any trajectory that would put the spacecraft in an extended eclipse. That alone eliminates a lot of potential dates.
The return profile matters too. Orion needs a specific entry angle and conditions for splashdown, so that further narrows the field.
Now, the reason we're talking about March and April specifically is that the first wet dress rehearsal, that's the full practice run of fueling and countdown procedures, ended early on February 2nd because of a liquid hydrogen leak. That took February off the table entirely.
A second wet dress attempt is expected soon, possibly this weekend, and NASA officials have been reassuring everyone that there are launch opportunities in every month beyond April as well. They just haven't published those dates yet.
And it's worth remembering that Artemis 1 had similar hydrogen leak issues and still flew successfully in late 2022, so this isn't uncharted territory.
Whenever it flies, it'll be historic. No astronaut has been beyond low Earth orbit since Apollo 17 in December 1972. That's over 53 years.
Moving on to our next story, and it's time for some pure cosmic beauty. NASA has released a breathtaking new image from the Hubble Space Telescope showing the Egg Nebula in extraordinary detail.
The Egg Nebula is about 1,000 light-years away in the constellation Cygnus, and it's what astronomers call a pre-planetary nebula, which, despite the name, has nothing to do with planets forming. It's the early stage of a dying sun-like star, shedding its outer layers.
And NASA describes it as the first, youngest, and closest pre-planetary nebula ever discovered, which makes it incredibly valuable for studying how stars like our sun eventually meet their end.
What makes this image so striking is the structure. At the center, you have the dying star, the yolk of the egg, hidden behind a dense cloud of dust. Twin beams of light punch outward through gaps in that dusty shell, illuminating a series of concentric arcs of gas that ripple outward like waves.
And unlike most nebulae, which glow because their gas has been ionized, the Egg Nebula shines purely by reflected light from the central star. The star hasn't heated up enough yet to ionize its surroundings. That's what makes this a pre-planetary nebula rather than a full planetary nebula.
The symmetry is remarkable too. Scientists say the patterns are far too orderly to have come from a violent event like a supernova. Instead, they point to coordinated sputtering events in the carbon-enriched core of the dying star, though the exact mechanism is still poorly understood.
There's also evidence of gravitational interactions with one or more hidden companion stars buried deep within the dust, which may be helping to shape those dramatic outflows.
This pre-planetary phase only lasts a few thousand years, an absolute blink in cosmic terms. So catching a nebula at this stage is like catching lightning in a bottle. And the material being shed here is the same kind of carbon-rich stardust that seeded our own solar system 4.5 billion years ago.
Hubble has observed the Egg Nebula before, but this new image, taken with the Wide Field Camera 3, combines multiple datasets to produce the most detailed portrait yet. 35 years in orbit, and Hubble is still delivering.
Now for a story that could fundamentally change how we think about Mars. New research published in the journal Astrobiology is making the case that NASA's Viking missions may have actually detected signs of life on Mars back in 1976. We just didn't know how to read the data.
This is a big claim, so let's unpack it. The Viking landers carried an instrument called the GCMS, the Gas Chromatography Mass Spectrometer, which was designed to detect organic molecules in the Martian soil. At the time, it returned what was interpreted as a negative result. No organics found, case closed.
And that conclusion essentially shut down the debate for decades. The Viking project scientist Gerald Soffen famously said, "No bodies, no life." And that became the textbook answer.
But here's the twist. In 2008, NASA's Phoenix lander discovered perchlorates in the Martian soil. Perchlorates are powerful oxidizing chemicals, and it turns out they break down organic molecules when heated, which is exactly what the Viking GCMS did to its soil samples.
So in 2010, astrobiologist Rafael Navarro-Gonzalez showed that if you take organic material and heat it in the presence of perchlorate, you get methyl chloride and carbon dioxide, which is precisely the chemical signature that Viking detected and dismissed as either contamination or an unknown chemical process.
Lead author Dr. Benner puts it very directly. The GCMS didn't fail to discover organics, it did discover them through their degradation products. We just didn't understand what we were looking at.
The team has even developed a model for what Martian microbes might look like. They call it barsoom. That's bacterial autotrophs that respire with stored oxygen on Mars. The idea is that these organisms could photosynthesize during the Martian day, produce and store oxygen, then use it to survive the freezing Martian nights.
I should emphasize, this doesn't prove there's life on Mars. But it does reopen a door that was closed 50 years ago and makes a compelling case that the evidence was there all along, hiding in plain sight.
And it raises a fascinating question. If we go back to Mars with modern instruments designed with perchlorates in mind, what else might we find?
Our final story today is a bit of a cosmic cold case. Remember Comet C 2019 Y4 Atlas?
Oh, the pandemic comet. It was discovered in December 2019, and as it flew toward the inner solar system in early 2020, it brightened so rapidly that astronomers predicted it could become visible to the naked eye, a real lockdown spectacle.
And then, like so many plans in 2020, it fell apart. Literally. In late April 2020, the comet dramatically disintegrated into dozens of pieces. Hubble tracked about 30 fragments grouped into a few clusters of icy debris.
But here's the thing. A new study in the Astronomical Journal by a team led by Salvatore Cordoba Quijano at Boston University has been asking if anything is still out there. Did the comet completely destroy itself, or could a chunk have survived?
The team scanned the skies in August and October of 2020 using the Lowell Discovery Telescope in Arizona and the Zwicky Transient Facility, which surveys the entire northern sky every 2 nights. They found nothing.
But, and this is the intriguing part, that doesn't necessarily mean there's nothing left. Their analysis suggests that a fragment up to about half a kilometer wide could still exist, but would be too small and too faint for those telescopes to detect. It could be out there right now, quietly tracing the comet's original orbit back toward the outer solar system.
The researchers pose a really thought-provoking question. How many comets that we've assumed were completely destroyed might actually have surviving remnants still orbiting the sun?
And there's a wonderful historical footnote here. Comet Atlas is believed to be a fragment of the same parent body as the Great Comet of 1844, which itself may have been visible to Stone Age civilizations about 5,000 years ago when it swept past the sun.
So somewhere out there, a tiny piece of a 5,000-year-old cosmic traveler might still be making its lonely journey through the darkness. I find that oddly beautiful.
Me too, and the study serves as a heads up to astronomers. Next time a comet breaks apart, be ready to keep watching because the story might not be over.
And that is your Astronomy Daily for Thursday, February 12th, 2026. What a lineup, from China's moon ambitions to Viking's long-lost life clues. If you enjoyed the show, please do leave us a review on your podcast platform of choice. It really does help new listeners find us. And you can find full show notes, links to all our sources, and more at astronomydaily.io.
For Avery and the whole Astronomy Daily team, I'm Anna. Keep looking up, and we'll see you tomorrow.